In this section, we are going to have a brief introduction to experiments. Experiments are essential in business because they allow us to infer causality. Until now, we have worked with observational data, and we could only say that a variable x is associated with a variable y. With experiments, we will be able to say that x causes a change in y. Let's look at an example. We are looking at a dataset of alumni donations. It contains the 2004 contributions received by a college, and the alumni are the people who graduated in various range of years from 1957 to 1997. We also know what donations they made in the past between 2001 and 2003, and we know if they attended an alumni event. How would you use this data to determine whether hosting events for alumni is worth the expenses? Here are some statistics that could be useful. We are looking at the group of alumni who attended events and another group of alumni who didn't attend events. In the group who didn't attend events, at the top, we had 22% of the people donating, and the average amount was $29.46. In the group who attended events, we had nearly half of the people donating, 48.1%, and the average amount was $221 and a few cents. So we have a clear association here, and we can say that on average, people attending are more likely to donate, and that when they donate, they give a larger amount. We might conclude that hosting events is useful to increase donations. What is wrong with this reasoning? There might be other factors that explain why people who attend events are more likely to donate and why they donate more on average. For instance, maybe organizers are more likely to invite people who donated in the past and they want to thank them. So these people would donate more even if they weren't invited. It might be that people who want to attend events are also the people who really care about the college. So they would also donate more even if there weren't any event held or if they weren't invited. It might be correlated with many other factors. The organizer might focus on the richest alumni, or people who are free to attend events, they have more flexibility with regard to job or family, and so they also have more flexibility in terms of donation. You can think of many other factors like this. You could try to run a regression with additional explanatory variables to control for these factors, such as past donations or demographics. However, you might not have these data, and even if you have these data, it doesn't solve the causality issue. You still cannot say that the events cause donations to increase. One of the causality issue is the potential reverse or bidirectional causality. You could have different causal patterns. Maybe if you made big donations in the past, you're more likely to be invited. Or maybe you are invited and then you are more likely to make big donations because it motivates you to donate. Maybe you have a bit of both. So if there is a reverse or a bidirectional causality, we cannot estimate the effect of event attendance on donation from this dataset alone. Another issue might be a confounding or a latent variable issue. A confound is a variable that affects both our x and our y. A latent variable is a variable that we don't observe. It's not in our model. So here, for instance, wealth would be the latent variable z, and it could affect the invitation, so x, and also the donation. If you are wealthy, you might be more likely to donate. Wealth might not be observed either, so even if we wanted to include it in our model, we couldn't. If you have confounding variables like this, you cannot separate the effect of wealth from the effect of being invited. So you don't know what share of the donation is due to being wealthy and what share is due to being invited. In this case, we cannot estimate the effect of event attendance on donation from this data without controlling for these latent or confounding variable. So you need to add them to the regression, but by definition, if it's a latent variable, you might not have the data to begin with. Finally, the answer you get might vary from an analyst to another because it depends on subjective decisions. One analyst might have some variables in the model and another analyst might control for other variables. Some analysts might use one model and another analyst might use another model, and so they will reach different conclusions. Even the most careful or experimented analyst may not answer the causal question, how much does attending an event increase the propensity to donate or the amount given? It is just impossible to measure the causal effect with observational data. As we already know, we cannot interpret observational data in a causal sense. A correlation does not imply a causation. The easy solution is to run a randomized experiment. The only surefire way to prove that something you do causes an outcome is to run a randomized experiment. To do that, we take a big group and we randomly split it into 2 or more groups, and then we apply the treatment to one group and not the other. Then we compare the result, and we know that the treatment had an effect this time on the outcome. So what's happening? Well, if we decide whom to invite by flipping a coin, then we are sure it's random, and so it's not linked with any other variable, z, that is confounded or latent. In that case, we broke the link between z and x, and so we are sure that x caused the change in y between these groups. So randomization ensures that our variable of interest, the treatment x, is not correlated or dependent on any latent or confounded variable. That will allow us to have a causal interpretation.